Okay, so I want to go through this example script to kind of show you how we would go about making a script that kind of combines a lot of these different tools together. So first thing I'm going to do is go back to my shell here, and I'm going to exit out of this shell, and in fact I'm going to source deactivate. And I haven't been doing this, but if you followed along with the bash profile commands that I suggested, you might be able to type an up arrow, and it will show you all the different commands that you type beginning with source. So this is a way to shortcut having to type the whole command. So you deactivate that environment, and now we're going to do a source activate Python 3. So we're now in our Python 3 Conda environment. And I think let's do this. So let's go ahead and copy from here. This is just a comment. We're going to copy this text all the way down to the end of the file, which is here. So you might be able to do what I just did, where you hold the shift button and then click, and it will highlight the whole thing. You can then copy that, and then you can do a couple things, but the easiest thing is to do a cat, and then we're gonna this should be a new file, so we can do survey underscore SIO209.py, and now we have an empty prompt, right? So we can just hit paste, whatever your paste command is. For me, it's Command V. I'm going to hit enter one more time so I have a new line, and then Control C, which will exit out of that. You could also have opened up your text editor and pasted it that way. And in fact, that's what I want to do. So I have a shortcut, Sublime, which will open up Sublime Text, or you can just go to your text editor here and open up Atom or Sublime Text, whatever you prefer. So is everyone able to open up this text file, have their own copy? So what this is now is this is a Python script that we've copied from the lesson, and we now have on our computer. So this is a script that can be run locally on our computer, and it will run through all these commands as a single program. So let's actually try to run it first, and then we'll go back and see what it was doing. So if we're in our, I can type clear again to clear my screen. If we're in, but you don't have to, it doesn't do anything except just make it look less cluttered. So I can type ls, and I can see what's in this file, this directory. So I have this survey SIO209. So I'm going to type Python. So when I type Python, it's going to use the version of Python that's in this Python 3 environment. So it should be a Python 3, 3.7 or 3.6. I can check by typing Python -- version. And then what I want to do is type Python and then survey underscore SIO209.py. And this is going to run this script on my computer. I hit enter, and it prints this text, and it says please answer the following questions. So you can go ahead and fill out this survey. You can type your name. If I have my own laptop, I can type Y, or actually I can type yes also. We'll see what that does. Which operating system? I can fill out the answer. And now it's saying for the following questions, what's your experience? Remember, you did this on the Google survey at the beginning of class, but this is a different way of doing the same thing. So what's your experience with command line? I can say, well, I'm pretty experienced. Bash, pretty good. R, some experience. I can fill these out. Anyway, it doesn't matter what you put. However, as we'll see, if you put something that's not allowed, it will give you should give you an error message. But then when you're done, it's going to say thank you for completing the survey, and then your answers have been stored in the file answers.lukethompson.csv. So I can then look at what's in this folder, and I can see, indeed, I have this CSV file called answers.lukethompson.csv. So if I look at that, I see there's this CSV file stored with my answers. So all of you should have something like that now in your directory. So let's see how we did this. So what happened when we executed the script was, first thing it did was it printed this block of text. So it says print, and then we have 3 quote marks. This is a block of text, so we don't have to put new line characters here because it's a big block, so it just interprets it kind of literally. So it printed first a new line. This is a new line here, and then these hash signs, and printed this little header. The next thing it does is it defines these functions. So we don't see anything. It doesn't ask us for any information. This is all just happening internally, that the Python interpreter is reading these functions and storing them in the memory of the computer. So we have one function called get free text, and it's going to take a prompt, and we'll see where this prompt comes from later. And it's going to then ask for input using that prompt. It's going to store that as an answer, and it's going to return the answer. And by the way, when we were talking about functions, I said you can put the return statement in parentheses, but I actually take that back. So return is not a function of itself. It's actually another kind of operator of Python. So it doesn't really matter, I think, but you're better off just not using. Just like when we write def, we don't put a parentheses, we just put a space. Or we use that del that we saw earlier, delete, that we just put a space there. So same thing with return. We just put a space here. But this is going to return the answer. So that function will then this is a function that gets input from the user and returns that to the program. So then we've got another function that it's called getScore. This will also have a prompt, and it's going to ask for an answer. And if that answer is a 0, 1, 2, or 3, it will break out of this loop. Otherwise, it's going to keep asking you to enter a number from 0 to 3. So this is in a while loop, and I used this trick where I said while true. So a while loop that says while true, will that loop ever not be executed? No, right? It's always going to be executed. So how do I get out of a loop? Otherwise, it's what they call an infinite loop. So infinite loop is not just where Apple Computer is located. It's also a computer science term, right? An infinite loop is something you want to avoid because your program will never, ever end. So I did this on purpose, though, because I know that if they answer a 0, 1, 2, or 3, it will break out of the loop. So this is a trick you can use to break out. Okay, then there's another function, which is a get yes or no. This is same kind of thing. We start as a we start as our answer as having no value. So, and then it says while answer is not in yes or no, ask for an answer. So until you enter a y or an n, it's going to keep asking you for an answer. And then I added this thing here where it takes the first letter of your answer and converts it to uppercase, and then that needs to be a y or an n. So this way, if you write yes lowercase, it will still understand that as a yes. Or if I say YOLO, it would interpret that as yes. Or if I say nada, it would interpret that as no. So it's a little bit loose, but it gives you the opportunity to, like, I don't know. Anyway, yeah. It capitalizes it, yeah. So it does upper. Yeah, we'll see in a minute how you can play with this. And then there's other ways to do it. You could ask for it to be like case insensitive, but and then get computer. So you say while answer is not in Mac, Linux, or Windows, you have to write, and here you have to write exactly how it's written. Okay, so these are just the functions. So we usually define the functions at the beginning, and then we have the rest of our program. So now we're ready to actually run the program. So the first thing it does is it says first name equals get free text first name. So now it's using this function up here, get free text, and then that's going to use a prompt to get an answer. So this is the prompt, and then the answer gets stored as first name. And so same thing for last name, and then for the computer yes no, it uses this function get yes no. So actually you can see in Sublime Text it's smart. It knows this is a function, and it says the definition for this function is on line 24. So that's pretty cool. And then here it says reference, so this function is used on line 41. Anyway, so it's gonna then do this get yes no and return that answer, and then operating system will be the answer of get computer. Okay, then now we've got some additional questions. So we want to get these scores, or these like responses for all these different computing tools, and so it prints out this block of text saying, for the following questions, give a number from 0 to 3, and it defines what those are. So this is where this part comes in, and then it goes and asks, uses this get score function, which is defined up here on line 15. In fact, I think I can click. Oh, yeah, that's pretty cool. And then so it gets the score, and then what it does is so now it has all the information as individual variables. Then it makes a dictionary where you have keys as these names of these entries, and the values as the values of those different variables. It sorts the dictionary in this case, because I'm not sure. I actually wrote this program for Python 2, so I wanted to make sure that the dictionary was, I was going to go through the dictionary in order. So now I have a dictionary of all the answers. I have the keys sorted, so the dictionary can be printed in order. And then I create an out file. So what I'm doing is I'm going to say I want the out file, this is just the file I'm going to save, to be answers underscore first name plus an underscore plus last name plus .csv. That's just the name of the file. And then I say I'm going to open that out file to write, and then remember I could have done a with block, but I didn't here. And I say for each key in this list of keys, I'm going to do that target file, which is f.write and then I'm going to write two things separated by parentheses and then a new line. So it's going to be the key and then the value. And then I'm going to close. And so that file's been written, and then I just print this. We just print this, thank you message. It says, thank you for completing the survey. Your answers have been stored in the file here, and then the name of the file is then repeated. I could have just written out file, and probably that would have been better form to do that. So in fact, let's just do that. Yeah, that's it. That's a cleaner thing. In coding, you want to avoid doing the same calculation multiple times. It's wasteful to create that file name twice, and I also might make a mistake. So better to not do that. Another thing I can do here is, I'll leave it. I could do the with thing, but okay, so I'm going to save that. So let's go now and just run through this again. So we're going to do Python survey. I can change my name this time. And if I say, now remember this yes no thing. I said it kind of, if I type anything beginning with a Y, it'll get interpreted as a yes. But what if I say, I don't know. It's going to ask me again. So what's happening here is this. This is a yes no. This is our yes no function. While the answer is not Y or N, it's going to keep asking. So right, it's going to keep asking. But if I say it interpreted that as yes. So that's just the way I wrote it. You could make it a little more precise, but just to show you that it converted that Y to a single character and then said, yeah, it's valid. So if I say I have a PC or a Mac, it doesn't like that. I have to spell it. This one I have to spell it right because of the way I wrote the function. Now same thing with the survey here. If I say, 4, it's going to give me, says I must enter a number from 0 to 3. Let's say 0, no, so I have to enter, etc. So that's the idea here. We have this loop, this while statement that will only be satisfied if I enter an answer that it's asking for. And it worked properly at the end here. I changed this so it now says out file, but I still get the out file, and now I have two sets of answers. So this is a moderately, it's not the simplest Python script, but it's not too complicated either, and it uses a lot of the things that we've covered so far. So let's go back. So, okay. So let's do a few more IPython things. So let's go back to our shell, and we're in the Python 3 environment, so that's good. I'm going to type IPython. And again, it's Python 3.7. So again, there gives you some information at the top. It says you can type question mark for help. So this is going to generate this nice help documentation. For example, I can type an object and a question mark, and it will give me information about that object. I can type a double question mark, and it'll give me extra detailed information. I can type percent quick ref, and it'll give me a quick reference of the IPython syntax and magic commands. we'll talk about magic commands in a minute. And so a lot of nice information. This is kind of like the man page for IPython. So if I want to exit, I can hit quit or hit Q. So as it shows here, if I have, there's tab completion is an important feature of IPython. So if I have two variables that are very similar, and then I start to type them, it's going to help me out. And in fact, it's going to give me these two variables, but it's also going to give me some Python keywords like and any. It's also going to give me these two files that are in my working directory, because IPython knows about the local environment, and maybe I want to import one of these files, so it knows about those. So I can use that tab button a lot to get useful things. Also, it tells you something about an object. So if B is a list, you can type B dot tab, and it's going to give me all these methods for a list. So I can reverse that list. Now if I just type enter here, what it's saying is this B dot reverse, that's a function or a method of a list. If I actually want to execute that function, I have to put the parentheses there. That tells Python that's I want to execute that function. I don't just want to return the type of that function. So now I've reversed that list. And if I wanted to find out more about that object, I could type a question mark. And this is a type list. It has this form as a string, has length 3, and some more information. If I want even more information, in this case there's not a lot of extra information given by the double question mark, but for some objects there will be. And if I want, say I import this date time module, we'll spend a whole lesson talking about time series in Python, especially using pandas. If I type date time dot, I get all these things. So I can say, let's say I type date. Oh, I need to. Okay, I don't remember how that function works. Or I could do this. Oh, I think it just converts it to a date object. Yeah. Anyway, we'll spend a lot of time on that. Don't worry. But this is just to show you that we have this package that now gives us all these different options. We can see all the different functions that we have available with that module. Another thing we do, so there's an example here, but if we wanted to run, let's see if this works. So let's do, this is one of the magic commands. So it's a magic command called run. So we're going to run survey SIO209. And now it's going to, inside the IPython shell, and you could do this in Jupyter as well. Although I don't know, this wouldn't work so well with Jupyter, but it might work. We can enter a survey here. Now we can I believe we should be able to see all of the variables that have been created using this dir command. Yeah. So there's a lot of special variables that we'll talk about in a minute, but what you can see also is this, all of the functions and especially all of the variables that we just created are now in our space. So normally when you run a Python script, it runs, and then when it's done running, everything kind of goes away. But when you run the script inside the IPython shell, you keep all the information. So if I can type score bash, and it's 2, because when it asked me, what was my experience with bash, I wrote 2. So that value was stored, and it's still available now in the shell. So this is a cool way if you're debugging your code, or you want to kind of both have a script but also be able to run it in an interactive environment where you can play around with things. This is a nice, handy thing. So there's a bunch more magic commands like run. So there's one called quick-ref. And this will give us a quick reference for the IPython shell. It's kind of like a reference card. There's one called who, which will give us just a list of all the variables, or one that's a little more useful is whose. This will give us all of the variables plus their type and some information about the data that they contain. So we have things that we entered in this shell, like an apple and an example, but we also have all these variables that we created when we ran that script, and we have some functions as well. All this stuff is available now. We can reset all the variables if we want. We can get a command history. We can get information about other magic commands. Another one that we can do is we can get information about we can run shell commands from here. So some shell commands will work. Like we can try to type ls, that works. But if we try pwd, we get, actually this is treated more like a we get the output as sort of a Python output. But if we type pwd this way, it works more like a shell command. What would be another good example? We can do like which Python. So this gives us an error if we just type it like this, but if we type it with an exclamation mark at the beginning, the IPython shell will interpret this as a bash command and not as a Python command. So this is handy. You don't have to exit out to a normal bash shell to have access to bash commands. Also, there's command history. So if we don't have to do this exactly like this, but we can see, so for example, this in line 19, I wrote score bash. So if I go and type in 19, it's going to run that command again. So the way this works is that in is actually a list of commands that have indices. So when I type in 19, I'm getting the 19th command that I typed, and so I can refer to previous commands using these numerical indexes. And the same thing is true for out, except out is a dictionary. And I think it does it this way because the input commands are always going to be sequential from the beginning to the end. Whereas out commands, there might not always be an output for every command, so it uses a dictionary. So we wanted the output of line 28, which was score bash. We could type out 28. For you guys, of course, it might be different, your line numbers, but if you want more practice with this, you can start a new shell and enter in these commands, and you'll get the same line numbers. We also have some shortcuts. So for output of command 1, we can do _1. For input of line 1, we can do _I1. Or if we just want the previous output, we can do a single underscore, or the two commands before, we can do a double. So that's kind of a preview of, or an overview of some of the more advanced features of the interactive Python, or IPython. So I've also put here a command review for the notebook. So you can pull this up by going to help and the keyboard shortcuts, but I've just put it here as a handy thing. If you want, you could print this out and put it next to your computer, so you can start to learn some of these shortcuts. We've been doing things like Shift-Enter and A for above and B for below, like adding a cell above or below. And it says how you switch between these two modes. Either hitting Enter to edit or Escape to go back to command mode. So spend some time looking at these commands either here or directly in your notebook. So this should be the same as you get in your notebook. Finally, we covered the star operator a few lessons ago, but we didn't really dig into it, and I probably didn't give the clearest explanation. So I found a better explanation that I can describe today. So basically, we're going to actually go back to the notebook here. So let's go exit, and we're still in lessons, so we can type Jupyter Notebook, and we're going to go to lesson 8. And we can scroll all the way to the bottom. Okay. So what we're going to do here is we're going to see how the single star and the double star work. So when you run a function with a single star, it will unpack this sequence of arguments into positional arguments. So this function, so there's sort of three things going on in this block. So first we're defining a function called sum, which will takes two arguments and returns their sum. And then we're going to specify values as a tuple, having two values. And then we're going to run sum star values, which will unpack that tuple into two separate values, which can then be used. And those are positional arguments, so the order will be the same order that they're used in the function. So if we execute this block, we get the answer 3. So it's unpacking 1 and 2 as two separate things and adding them. So this is what's actually happening. It's basically doing 1 and 2 separately, but it unpacks it this way. The double star is similar, but it uses a dictionary instead of positional arguments. So it uses named arguments. So we can say the values are A and B, and they have these values 1 and 2, and then we can sum them this way. So using the double star, it just looks for the values of those two things. So we can also combine these two things together. So if we have a function that takes four arguments, we can say we have 2 values here and 2 values here. We can then combine them with commas, and it will take 1, 2, 10, and 15, like this. So this is the same as doing this type of function. And it works because, so notice how this function takes C and D. So these are, in this case, these are not interpreted as, the positions are not needed because we're actually saying C is 10. So we could change the order of these, and we get the same. Wouldn't affect the output. So additionally, we can kind of switch this around, and we can define functions that take multiple values. This is actually, I think, more useful. So here we're defining a function called sum, which takes any number of values, which are just in order, and we have to kind of do a for loop through all these values to get all the information. So in this case, it's a sum, so we're going to set s as 0, and then for each value, we're going to add that to the sum, and then generate, this will then generate the sum of all 5 values. So we could have 2 or 100 or any number of values, and this function would work. So that's a really handy way to take an unknown number of values. Similarly, let's say we want to take a dictionary that has, basically a dictionary that has, we know it has some key, but it might have many other keys, but we only want the information from that one key. So this one's called get A, and it takes this set of named arguments, and it's only going to give us the value of A no matter what else is in that set of arguments. So this, for example, this allows us to have optional parameters in our function. So we can have a function sum that will sum these values, but if there's an option neg, so if this options dictionary contains a key called neg, it's going to say if it's true, then it will give us the inverse, or the not the inverse, but the opposite of the sum. So it will negate the sum. So when we just run this function normally, when there's no option neg, it's just going to sum the values. None of this part here will be used. But if we provide an additional option called neg, it's going to say, oh, okay, this is in the options. Now, is it true? So this if thing is going to say if this expression is true. Well, if it's set to true, then it is true. Then it will give us the opposite. That's what's happening here. Where if it's set to false, then this part, even though there is an option that's provided, the value of that option is false. So this block will not, that if statement will not be executed or the part below the if statement will not be executed because it evaluates as false. So that doesn't get. So this is just one way to introduce potentially options to your functions. This is takes a little time to figure out what's happening here, but I think with some practice you'll get the hang of it. So that's all we have for today, and I'll be around to answer any questions.